Hi, everyone. For our group project, we're going to be walking through an AI prompting technique called meta prompting. I'll be covering the introduction, and my teammates will follow up with the key characteristics, its advantages over few shot prompting, and some real world applications. So, what exactly is meta prompting? At its core, it's a technique that focuses on the structure of a problem rather than its specific content. Instead of feeding an AI model detailed examples or rich subject matter, metaprompting uses syntax or abstract patterns as templates. The goal is to give the model a structured form to work with rather than filling in all the details yourself. You're essentially using the AI to optimize your inputs. Here's the big picture. Three different ideas define metaprompting. First, it's about structure over content, meaning one well formed prompt can actually work across many different topics. Second, it uses abstract frameworks, example templates that show the shape of a solution and not the specifics. And third, it's genuinely versatile. It's been applied to lots of different things like math problems, coding, reasoning tasks, and theoretical questions. So now my teammates will take you deeper into the other topics.
Howdy guys, my name is Joab. I'll be doing the key characteristics of meta prompting. So now that you've kind of learned at the introduction, first, meta prompting is structure oriented. So instead of focusing mainly on specific content, it focuses on overall format and pattern of a task. So this helps the AI understand how to approach problems more effectively. And second, meta prompting is syntax focused. So it uses organized wording and templates to guide the AI toward the type of response that's expected, making answers more consistent and clear. And then another important characteristic is the use of abstract examples. Instead of relying on detailed examples, meta prompting teaches general frameworks that can apply to many situations, right? And with that, meta prompting is also versatile because it can be used across many different fields like education, coding, business, research, right? So it like I said, it's versatile. And then finally, it uses a categorical approach, meaning it organizes information logically so the AI can better understand relationships between ideas. And then overall, these characteristics make metaprompting a more organized and flexible way to interact with AI. And next, we'll take a look at some of the advantages it has over few-shot prompting.
It's worth talking about the difference between meta prompting and another popular and widely used prompting framework called few-shot prompting. These are both powerful techniques, but they work in fundamentally different ways, and knowing when to use each one of them can make a big difference in the quality of the results. So let's break them down. I think first important point is that meta prompting and few-shot prompting are not competing approaches. They're distinct tools designed for different situations. And so the goal here is to kind of describe how to make an informed choice rather than defaulting to one or the other out of habit. The clearest way to understand the difference between these two approaches is through a few paired contrasts. So few-shot prompting is about showing. You give the model examples and let it infer the pattern that you've given it. And then meta-prompting is more about explaining, right? You describe the structure, the rules, or the process you want the model to follow. Few-shot focuses on the content, giving the model concrete instances of what you want. Meta prompting focuses on structure, telling the model how to think or how to respond. At the highest level, few-shot kind of answers the what does a good output look like versus meta prompting answers how should the model approach this task. Meta prompting does a few things particularly well. First of all, generalization is something that it's really good at because you're describing a method rather than providing the specific examples. So you're giving it a process to follow, and that process could be extrapolated to a lot of different things. A well-written meta prompt can handle a much wider range of inputs without needing to be rewritten. And secondly, it shines on complex multi-step tasks when a job requires planning, reasoning in stages, or constant structure across many outputs. And then finally, it's also good for token usage and efficiency, depending on the task, of course. But it can explaining the structure can be more efficient than providing a bunch of full examples, especially as those examples get longer. Few-shot prompting does have its place and its own strengths that make it a better choice in certain situations. The core idea is that sometimes showing is more effective than explaining. If the pattern you want is easier to demonstrate than describe, examples may get you there faster. And it's especially useful when you want immediate targeted improvements for a specific task. If you need the model to match a very particular tone or format or style, a handful of well-written, well-chosen examples often outperforms written instructions.
So here are some applications of meta prompting. It can be used for better research. Here's an example prompt. Act as an academic research assistant. Before answering, first identify the key concepts in the question, then generate 5 research sub-questions. rank them by importance, and answer them one at a time using reliable sources. A college student might use this for writing a research paper on AI ethics. It could also be used for coding. You could say, you are a senior software engineer mentoring a junior developer. Before writing code, explain the architecture choices, identify possible edge cases, then generate modular code with comments and unit tests. So someone might use this as a developer building a production web app. Without meta prompting, the AI may just jump straight into coding, ignore edge cases, produce messy architecture, and just overall give you a suboptimal result. With meta prompting, the AI knows the reasoning steps that you want it to go through to arrive at the result. So AI behaves more like an experienced engineer performing planning, validation, or structured implementation. And this can commonly be used in a variety of settings.